laws of motion. Yes, today's topic is friction. You all know about friction. Yes, what is friction? Which opposes motion of body. Yes, here we will see in detail what is friction. See, whenever two bodies they are in contact, some contact forces are produced. Okay, when two bodies are in contact, they are in contact. Contact forces are produced. Contact forces are produced. Okay. Now, such contact forces they obey Newton's third law of motion. Such contact forces obey Newton's third law of motion. Newton's third law of motion. Okay. Now, how they comes in contact and which forces are acting on it we will see in detail. But when two bodies are in contact, contact forces are produced. Contact forces obey Newton's third law of motion. Yes, we have to resolve these contact forces in two components. Okay, contact force is resolved in two components. First component perpendicular to contact surface. Perpendicular to contact surface is called normal force. And yes, it is denoted by n. And another component parallel to contact surface. Component parallel to contact surface is called frictional force. Or only friction. And it is denoted by small f. Yes, friction is denoted by small f. So remember, whenever two bodies are in contact, contact forces are produced. Contact forces obey Newton's third law of motion. Contact force is resolved in two components. Component perpendicular to contact surface is called normal force, and component parallel to contact surface is called frictional force or friction. Yes, in this chapter we have to see in detail for this friction. Okay. Yes, if you observe any surface with naked eyes, okay, yes, it seems to be smooth. But if you observe any surface with the help of microscope, okay, if you observe any surface with the help of microscope, it is at the micro level, it is like this, in form of reeds and valleys. Okay, so yes, whenever you observe any surface, then yes, any surface, it is in form of this reeds and valleys. Okay, so yes, whenever two objects are in contact, see, for example, I have object A. Okay, it is its surface if we see with the help of microscope. Okay, and I have another object B. Okay, if I have another object B, so whenever they are in contact, of first object or object B fits into values of object A. Into values of object A. Clear about this? Again, reach of one object fits into values of another object. Okay, so yes, between two objects, when they are in contact, when they are in contact, cold welding between two objects takes place. Okay, takes place. Clear about this? Okay, when they are in contact, cold welding between them takes place. Clear about this? And yes, it opposes motion, relative motion. It opposes relative motion between two objects. It opposes relative motion between two objects. Clear about this? So yes, it is how friction acts. Okay, if we see any object, then yes, I can see that this board is smooth, but no, it is not smooth. If you observe this board with the help of microscope, okay, yes, that surface is rough. That surface is rough. Rough means having reeds and valleys. Okay, so yes, whenever two objects they come in contact with each other, okay, yes, reeds and valleys of two objects they fit into each other, cold welding takes place, and it opposes relative motion between two objects. Clear about this? So it is how friction acts. You know about friction, that friction opposes motion. Clear about this? Okay, now friction, there are types of friction: static friction, kinetic friction, rolling friction. Okay, now first of all we will discuss about static friction. See, here it is. First of all we will discuss about static friction. Static friction, it is denoted by Fs. Static friction, it is denoted by Fs. Okay, now see here. For example, on a table, one block is placed. So now here we have two objects, one block and one table. So see, when two bodies are in contact, contact forces are produced. Clear about this? Okay, when two bodies are in contact forces are produced. Contact forces obey Newton's third law of motion. How? See, this block having mass m, mass of block is m. To see, if any object having mass m, then there is always gravitational force acting on it, means its weight, and that weight is always towards the center of earth, means vertically downward direction. So yes, be clear about this. Okay, in this chapter, whenever you are given object having mass m, one force always acts on it, that is weight, gravitational force acting on it, and it is always vertically downward direction. Clear about this? So see, due to this block, first force is acting in this vertically downward direction, that is mg. Clear about this? Now, as this block is placed on this table, this mg force is exerted by block on table. So according to Newton's third law of motion, okay, contact forces obey Newton's third law of motion. Okay, see, block exerts some force on table, so table also exerts some force on block. Yes or no? And yes, we have to resolve such contact forces in two components. See, it is called contact surface. It is called contact surface. See here, component perpendicular to contact surface is called normal force. So yes, here it is normal force. Here it is normal force. Remember, normal force is always perpendicular to contact surface. That's why it is named normal. Normal means perpendicular. Clear about this? So yes, here you are clear about this figure. Due to block, force acting on table is mg. Due to table, force acting on block is n. Clear about this? And yes, this block is in equilibrium. It is stationary. Okay, block is in equilibrium. Block is in equilibrium means it is stationary. That it is stationary, because equilibrium condition means two types of motion. First, stationary, and second, moving with uniform velocity. So yes, here I have assumed yes, it is in equilibrium condition. Now equilibrium condition means sigma f0. Yes or no? What is meaning of equilibrium? Equilibrium condition means sigma f0. So see here, this block is placed on table. mg is acting in vertically downward direction. N is acting in upward direction. Clear about this? Okay, so yes, if block is in equilibrium condition, it means this weight is balanced by this normal force. This weight is balanced by normal force, or this mg weight is cancelled by normal force, or resultant of these two forces is 0. Clear about this? Resultant of these two forces is 0. So yes, as block is in equilibrium condition, it is stationary. So I can write weight of block, that is mg, is equal to normal reaction. Is equal to normal reaction. Okay, and yes, they both are having same magnitude and opposite direction. They both are having same magnitude and opposite direction. So yes, mg balances n. This gravitational force balances n. Means the resultant is 0. Clear about this? Clear about this? Okay. Yes. Right now, how many forces are acting? Two forces, mg and n. Mg and n. Yes. Now, see, here it is. If I apply some external force on this block in this direction, if I apply some external force, on this block in this direction, okay, and block does not move, it does not come in motion. Understand? If I am applying, see, these two forces cancel out each other. So yes, they will cancel out effect of each other. Now if I am applying external force F, and if object is not coming in motion, then what is meaning of that? What is meaning of that? If I am here, something is pulling, okay, someone pulled me in this direction, and if I does not move, then what is meaning of that? Yes, according to Newton's third law of motion, or according to equilibrium of particle, we can say that there must be some force which acts in opposite direction. And yes, if the resultant becomes 0, then and then it will be in stationary condition. It will be in stationary condition. So yes, here when I apply external force F in this direction, and object does not comes in motion, object does not move, it means there is some another force in opposite direction. There is some another force in opposite direction. Clear about this? Clear about this? Okay, because we know that if only one force acts, then object moves with acceleration. If only one force acts, then object moves with acceleration. Okay, so here understand, if external force external force F is applied and object does not move, it means then there is another force present, which balances external force, and that force is nothing but frictional force. And yes, that force is friction. Static friction Fs. Clear about this? So see, understand, if I am applying external force on this object, it does not move, it means there is some another force in opposite direction which balances this external force, and that force is nothing but, see, in this direction, that force is nothing but friction force. Clear about this? See, this second component parallel to contact surface is called frictional force or friction. Component parallel to contact surface is called frictional force. And as this frictional force keeps this object in stationary condition, it is called static friction. So do you understand why it is named static friction? Yes, this frictional force keeps this object in stationary condition. That's why it is called static friction. Clear about this? Okay, so yes, again we have one block placed on table, mg acting in downward direction. Normal force, it is acting in upward direction, means normal to contact surface. These two forces, yes, they are contact forces. Obey Newton's third law of motion. So according to Newton's third law of motion, they will cancel out the effect of each other. Resultant of N and mg is 0. Now in this situation, if I apply external force on this block and the block is not moving, it means, yes, there must be some another force acting in opposite direction which balances this force and object remains stationary. Clear about this? That force which is opposing its motion is called static friction and keeps object in stationary condition. Okay, so yes, static friction is acting when object is in rest condition. Static friction keeps object in rest condition. Clear about this? Okay, now yes, we have to see in detail about the static friction. See, yes, again, if we have a block placed on table, mg vertically downward direction always, normal reaction always perpendicular to contact surface. Yes, these two forces will cancel out each other. If I am applying external force and body does not come in motion, it means there must be some another force which is acting in opposite direction and balances this force. So yes, here as block is stationary. Fs means static friction. Balances external force. It balances external force F. Clear about this? Okay. Now, if we increase external force, I am applying more external force, and still body is not moving, and still body is not moving, then it means force which is acting in opposite direction, which is static friction, also increases. So yes, if we increase external force F and block does not move, it means static friction also Fs also increases. Clear about this? Again, if I am applying more and more external force and this block is not moving, means static friction in opposite direction also increases. So yes, that's why this static friction Fs is called self-adjusting force. Why self-adjusting force? As external force increases, block does not move, friction force increases. As external force increases, block does not move, it also increases. Clear about this? So yes, that's why it is called self-adjusting force. But we know that if we apply more and more external force, after some particular value of external force, object will come in motion. Clear about this? So yes, for that particular value of external force, we will have some particular value of static friction called maximum static friction. Yes, this static friction increases up to some limit. This static friction Fs increases up to some limit. Okay, it increases up to some limit. If I am applying this external force greater than some particular value of this static friction, then object will come in motion, and that particular value of static friction is called maximum static friction. So here static friction Fs increases up to some limit, which is called maximum static friction. Okay, and if I am applying force greater than maximum static friction Fs maximum, object comes in motion. Here when we apply external force capital F more than Fs maximum, means maximum static friction, object comes in motion. Clear about this? So what is maximum static friction? When object is on verge of starting of its motion, value of static friction is called maximum static friction. Fs maximum. Clear about this? So again, external force is applied, body does not move, means static friction is acting in opposite direction. External force increases, does not move, Fs also increases. External forces increase, again not moving, Fs also increases, but external force, and due to that maximum static friction, it increases up to some particular limit. If I am applying force greater than that some specific value, that is Fs maximum, object comes in motion. Object comes in motion. Clear about this? So what is maximum static friction? For example, if I say I have this object. For this object, Fs maximum is equal to 50 Newton. Understand? For this object, if Fs maximum is equal to 50 Newton, it means if on this block I am applying external force 10 Newton, will this block come in motion? No. If I am applying external force 20 Newton, in motion? No. If I am applying external force F is equal to 30 Newton, motion? No. 40 Newton, motion? No. 45 Newton, motion? No. 50 Newton, motion? No. But if I increase that force, external force, greater than 50 Newton, that object will come in motion. Object will come in motion. Clear about this? So yes, it is meaning of maximum static friction. If maximum static friction is 50 Newton, then if I apply external force greater than 50 Newton, then object comes in motion. Otherwise it will not. Clear about this? Now, this maximum static friction, Fs maximum, it is independent of contact area. Fs maximum depends directly proportional to normal force. Fs maximum is directly proportional to normal force. And yes, we can write this as Fs maximum is proportional to n. And if we remove proportionality, we have to add some constant. Then that Fs maximum is equal to, it is mu s into n, where this mu s is called coefficient of static friction. Clear about this? Coefficient of static friction. Yes, for rough surface, this mu s is more. For smooth surface, value of mu s is less. So yes, here you have to remember this equation. Fs maximum is equal to mu s into n, or yes, mu s is equal to Fs maximum upon n. Mu s is equal to Fs maximum upon n. Yes, you have to remember this equation. Okay. What is law of static friction? Okay, Fs is less than or equal to mu s into n. Fs less than or equal to mu s into n. Okay, and what is meaning of this equation? See, if external force is less than Fs maximum, okay, object will not be in motion. But if external force F is greater than Fs maximum, object will start its motion. Clear about this? So yes, in today's lecture we have discussed about what is friction and what is static friction. Clear about this? Why static friction is called self-adjusting force? Because it changes according to external force. Clear about this? Write down these notes, send notes on Google Classroom, and if yes, if you have any doubt, then contact teachers.